In the digital world, cybercriminals are basically masters of disguise. They create this nasty, malicious software, and then they go to these incredible lengths to cover their tracks. What they leave behind is this cryptic puzzle for cybersecurity experts. But today, we're going to dive into some amazing new research that shows how an AI partner is learning to read those clues and crack the case wide open. Okay, so let's try a little thought experiment. Imagine you're trying to get around a huge city, but the map you have has no labels. Zero. You can see all the roads, all the buildings, but there are no street names, no landmarks, nothing. You see the structure, sure, but figuring out where you're going or what anything is for? Almost impossible, right? Well, that is pretty much exactly what cybercriminals do to their code. It's like they take a clear flowchart that says finance department or HR, and they just strip all the meaning out of it. They leave investigators with something that just says process B or task X. This is their main trick for hiding in plain sight. So there's a technical name for this digital mess. It's called stripped binary code. It's the raw software, but with all the helpful names and little signposts that the programmers originally put in, just gone. For the cyber detectives, this stripped code is the unreadable clue left at the scene of the crime. And that brings us right to our first section here, the code without labels. To really get a handle on this, we need to understand just how big of a problem this is for the good guys. I mean, just look at the difference here. It's night and day. On one side, you've got the clean, easy-to-read source code, just like the programmer wrote it. And on the other, you have what the security analysts actually find. It's a total jumble of generic names and memory locations. Trying to figure out what this code is supposed to do is a gigantic headache for a human. All right, and this total mess of code leads us straight into our next section, the digital detective's dilemma. We're going to take a look at the old way of doing things and, well, why it just isn't working anymore. Professor Lynn Tan from Purdue University really hits the nail on the head with this. She says that without better tools, security pros have to do this by hand, and that it's slow, it's full of mistakes, and when you think about the sheer number of threats out there, it's just not practical. So, here's the bottom line. The old manual process is a huge bottleneck. It's way too slow to keep up with all the new malware, it's easy for a human to make a mistake, and it just doesn't scale. Not even close. Okay, so clearly, we need a new approach. The old way can't keep up. And this is where the story gets really interesting. What if? What if an AI could be trained to think like one of these expert analysts? Well, let's meet our AI decoder, ReSym. That's right. Researchers have built an AI-powered tool to be the partner that these cyber analysts have been waiting for, and its name is ReSym. So what is ReSym? Well, the name stands for Recovering Symbols, and it's a system that uses large language models, the same kind of tech behind things like ChatGPT, to analyze that stripped binary code. It basically copies the way a human expert would puzzle through the code to put all those missing labels back and make sense of the whole thing. And let me tell you, this isn't just some side project, it is a huge breakthrough. It was developed at Purdue University, and the paper introducing ReSym actually won a Distinguished Paper Award at one of the top cybersecurity conferences in the world. So people are taking notice. Okay, we know ReSym is a big deal, but how on earth does it actually work? In this next section, we're going to look at how this AI detective puts all the clues together. ReSym's approach is actually brilliant. It uses a kind of divide and conquer strategy. So instead of trying to solve the entire mystery all at once, it breaks the problem down into two smaller, more manageable tasks. Then it uses two specialized AIs to work on those tasks. And finally, a master reasoning system pulls all their findings together to solve the puzzle. Let's walk through it. ReSym starts with the exact same cryptic mess that would have a human analyst pulling their hair out. This is the first piece of evidence. Then its first little AI helper, called var decoder, jumps in. It looks at all the local variables and basically asks them, hey, what were you called before your names were stripped away? And what kind of information were you holding? At the same time, its second AI helper, field decoder, is focused on how all the different parts of the code talk to each other. It looks at the memory and asks, okay, when the code reaches into this structure, what specific piece of info is it trying to grab? And here it is, the big payoff. After those two AI agents do their thing and the master system puts it all together, that messy, unreadable code is totally transformed. It's restored to something that looks incredibly close to what the programmer originally wrote, with clear names and understandable logic. Suddenly, our map has street signs again. Now, this is all technically very, very cool. But the real question is, so what? What's the real-world impact? In our last section here, we're going to explore exactly why this matters so much. Well, for starters, it succeeds where other cutting-edge tools have failed. Older tools like Osprey could kind of figure out the structure of the data, but not the human-readable names. Others, like Dirty, could guess at the names, but couldn't handle the custom data structures. ReSym is the first tool that can actually do both, and do them well. And the stakes here could not be higher. By 2025, the annual cost of cybercrime is projected to hit $10.5 trillion. That's trillion with a T. We are in a digital arms race, and we need every single advantage we can get. And this is where ReSym could be an absolute game changer. Think about it. Faster, more accurate malware detection, finding hidden bugs in the software we all use every day. It could help secure our critical infrastructure. We're talking defense, healthcare, and even protect a company's secret sauce, its intellectual property. Like Professor Tan says again here, automating this whole process, it's not just a nice to have, it's essential. It is the key to finally scaling up our defenses to match the massive scale of the threats that we're facing. So this leaves us with a really fascinating thought. As all these digital threats get more and more complex, the future of our security isn't just going to be about building bigger walls. It's going to be about this powerful partnership between human expertise and really sophisticated AI reasoning, both working together to read the clues that others try so desperately to hide. And how that partnership evolves, well, that's going to define the next chapter in cybersecurity.